All right, let's see here. Let's start with the homework then. So today is going to be the third class of um, our first unit here, applications and complex numbers. That's what we're going to go over today. So let's go over the schedule. We're first, of course, going to go over the homework. Some of you forgot to check after the second question. So after the second question, you have to check your answers because one of them is incorrect. Then we're going to go over applications and then complex numbers. So let's start with the first question of the homework. So I'm going to give you guys a couple moments to just put your answers in the chat. Let's see what answers we got for this first question. Okay, so we got no solution, right? So this one has no solution. William says there is I, and that is correct. That is correct. There is I, imaginary numbers, but remember, we haven't learned about I yet. So it's fine if you said just no solution. So no real solutions should be correct. So no real numbers that can fit this equation and make it true. So if you look at this and we like plug it into the quadratic formula, we get x is equal to 4 plus or minus the square root of 16 minus 32, right? And then that's over 2. And we see that 4 plus or minus the square root of negative 16 over 2 doesn't work, right? That just doesn't work because you cannot take the square root of a negative number and get a real number. However, you could simplify this to 4i, right? And then you get 2 plus or minus 2i. But this we haven't talked about yet. We are going to talk about it in this class, actually, and this lesson, right? So it's fine if you got no solution. No real solutions should be correct, yeah. All right. So now let's go on to the second one and make sure you check your answer on this one. So it's very important to check your answer on this one. So let's go over this one. So we get x is equal to 5. Very good. So I'm going to call someone up to try this problem this time. How about William? So William, how did you solve this problem?
So first, I moved the 1 to the other side because I think solving x to plus 4 is much easier. So so it is equal to 2x plus 6 minus 1 equals the square root of x plus 4. Then I basically just did everything to the power of 2. So x plus 4 wait. So 2x plus 6 minus 2 times the square root of 2x plus 6 plus 1 equals to x plus 4. And that in basically negative x is equal to 3 minus 2 times the square root of 2x plus 6, and then negative x minus 3 equals to negative 2 times the square root of 2x plus 6. And I did everything to the power 2 again, so x to the power 2 plus 6x plus 9 is equal to 8x plus 24. Then x to the power 2 minus 2x minus 15 equals to 0. So I couldn't really factor this out that well. I mean, no, never mind. Yeah, I actually factored it out. So I found that x could be 5 or negative 3, but negative 3 doesn't work. So x is equal to 5.
All right, that's very good. So if you look at this, it's minus 2x, right? Minus 2x here.
Mhm.
And then it's 9 minus 24, which is
Minus
equal
15.
to 15 here, right? It can be factored. So then you get x is equal to 5 and negative 3. Okay, so after you get that, of course, the key point here is to check. You must check, right? So if you check negative 3, let's check negative 3. You get 0 is equal to 2. That's incorrect. So this is wrong. Now let's check 5. 5 is going to be 4 is equal to 3 plus 1, which is equal to 4. So this is correct. So then the answer is x is equal to 5. So you must check, because when you square something like this, it can create some small inaccuracies, if you think about it. Because negative 1 squared is equal to 1 squared. This does not imply that negative 1 is equal to 1. This does not imply that. So therefore, when you square something, it makes some mistakes sometimes. So that's why you always got to check. All right. Now, if we solve this third problem, all right, I'll give you a couple moments to solve this third problem here. All right, so let's solve this one. So we got -1 and 1. Those are the only real solutions. And there are some imaginary solutions where you get the square root of negative numbers, but we won't worry about that until we've learned about it. So let's see, who else wants to solve this problem this time? Let's see here. How about Eric? Eric, would you like to solve this problem? Okay, if not, then Kaylee. Kaylee, solve this problem.
Okay. So we set y and y is equal to x squared. And when we replace it, it's y squared plus 5y minus 6 is equal to 0. And we can factor that. Factored, it would be y plus 6 times y minus 1 equals 0. Then we substitute the x in, so x squared plus 6 times x squared minus 1 is equal to 0. That means that x squared plus 6 is equal to 0, or x squared minus 1 is equal to 0. If x squared plus 6 is equal to 0, you subtract 6 from both sides, so x squared is equal to negative 6. Then x is equal to the square root of negative 6, but that's impossible. So that's not a possible solution. Then we have x squared minus 1 is equal to 0. Then when we add 1 to both sides, and it's x squared is equal to 1, which means that x is equal to the square root of 1. And so x is equal to 1 or negative 1.
Very good. Great. That's very good. Any further questions about homework? If there are no further questions about homework, then we'll move on to applications. So I advise you strongly to take notes in this part of the lecture, because applications can be quite difficult, right? It can be quite hard if you don't quite get it. You have to like fully understand it, because you need to set up equations, and that can be difficult sometimes. So most of the application problems that we're going to be doing today are related to distance and is equal to rate times time. So where d is equal to distance, r is equal to the rate, and t is equal to the time. And that is the big equation that we are going to use, right? Doing these applications, and you're going to find that you need to use distance is equal to rate times time for a lot of these applications, right? Or we can have, like, for example, q is equal to r times time, where q is the quantity. It's the same idea, right? So without further ado, let's try this one. So I'm going to try this first example. I'm going to do this first example. I'm going to walk you through it. But the next few examples, I would like you guys to try first, and then we can do it. So first, of course, we need to write this up here because we're going to use it. The distance along a shipping route between San Francisco is equal to, and Honolulu is 2,100 nautical miles. If you don't know, San Francisco, city in California, and Honolulu is the capital of Hawaii. If one ship leaves San Francisco at the same time and another leaves Honolulu, and the former is traveling at 15 knots, meaning San Francisco is traveling at 15 knots, and the latter, the one leaving Honolulu, is traveling at 20 knots, how long will it take for these two ships to rendezvous? If you don't know what this word means, it just basically means to meet, right? So let's draw. Usually we try to draw like a diagram or something. I don't know what these states look like. I know like California, along the coastline. Hawaii, somewhere down here, probably. If you're good at geography, you can probably correct me. So San Francisco, right? Over here, Honolulu over here, right? This distance is going to be 2,100 nautical miles, right? And we know that one ship is leaving San Francisco. Like this is San Francisco, this is Honolulu. So we know that this ship leaving San Francisco is going to be at 15 knots. So let's just write that there. And that's going to be basically the rate. So we know that 15 knots is the rate, and we know that the 20 knots is the rate of the other boat. So let's just write all this information down. I think that's all we have right here. So what do we have? We have the distance, we have the rates, all we need is the time. And that's exactly what the question asks, right? How long will it take for these two ships to rendezvous? Okay. Let's see here. So I like to draw a chart, right? You also should draw a chart. So always draw this chart here. So we have distance, we have rate, and we have time. So the distance, of course, is going to be 2,100 and 2,100 here. And the rate is going to be 15 knots. Actually, for this one, this is going to be San Francisco, and this one is going to be Honolulu. Okay, just so we're clear on that. So the rate of the one leaving San Francisco is going to be going slower, that's 15 knots. And the one leaving Honolulu is 20 knots. And we need to find the time. Right. So how are we supposed to do this? So I'm going to give, after I've set up this chart, I'm going to give you guys a couple moments to try and find out how we do this. Okay, so I'm going to give you like 2 minutes here and try to figure out what equation we are going to set up. And I'm going to give you 2 minutes to do that, and then I'm going to walk you through it. Okay, so of course we're trying to find time. So how are we going to set this up? All right, I'll give you a few moments to do that, and then I'll walk you through it.
Wait, what is 1 knot?
1 knot is basically it's the rate. It's like miles per hour, except it's for like sailor. I'm not too sure about what a knot is, but I know that it's like the boats going at some speed. Like 50 knots is like a speed. It's like 15 miles per hour, but in a different setup, right?
So
it's
do we just
just like treat it as like a rate, right?
wait, so do we just assume that 15 knots is 15 nautical miles per hour?
I'm pretty sure it's nautical miles per hour. I'm not too sure, but I'm pretty sure you can assume that.
Okay.
I'm not too sure about knots. I'm not a sailor, but just try to do it right. Now I'll walk you through it, right? All right, so let's talk over this one. So we have a couple of answers here, right? 2,100 divided by 35. That's very good. Yes. So the answer is 60 hours. So let's do this for a second. Okay, so uh so we need to find t, right? So we don't know that. So let's just put that as t. We know it's some time, right? In hours, right? So these two boats, at one point in time, they're going to meet along this line, right? Whether it's here, right, or here, we know that the distances they have covered will add up to 2,100. So let's just do that real quick. So the distances of San Francisco plus the distances of Honolulu will add up. Will add up to 2,100 because they're heading towards each other, right? They're heading towards each other. So what is the distance of San Francisco? It's going to be 15 times t, right? And that's going to be added to 20 times t. So we get this very simple equation. We get 35. T is going to be equal to 2,100, and t is going to be equal to 60 hours. So that's how you set up a distance, rate, time problem, right? It's not too hard. You just have to, setting up the equation is the hardest part, and you just need to solve it afterwards. So let's try this next problem. So this one, I feel like it's significantly harder than the last one, because the last one was pretty easy, right? So this one steps it up a little bit. So I want you guys to just try and do this, right? Try and do this, and then I will walk you through it afterwards. So let's see. Okay, are there any ideas? Any questions though? Yes. Any ideas? Okay, I'll give you like 2 more minutes. Try and figure this out. If not, then I'll just walk you through it. All right, so we have x is equal to 3 miles per hour. That is actually correct. Great job, great job. Okay, so how do we actually do this? So first, of course, we want to, do the distance is equal to rate times time, right? But how do we actually do that? So let's try to envision this. So what exactly is this? An excursion boat takes 1.5 times as long to go 360 miles up a river than to return. So we know this river is 360 miles, right? Whether it's going up the river or it's going down the river, it's always going to be 360 miles. So of course we already we know that now. So let's have, this is going up the river and this is going down the river. So going up the river, we know the distance is going to be 360, and going down the river, it's still going to be 360. So what does it mean to have this 1.5 times as long as to go 360 miles per hour? So first we have to find out the rates. So we know the rates, it's going to be 15 plus or minus something, because it's 15 miles per hour in still water, right? In still water, and now it's going up a river and down a river. You're going to have to add or subtract the current, right? So when you're going up a river, it's going to be 15 minus r, because the current is going against you, so you're going slower, right? That's going to be 15 minus r here. So, and when you're going down the river, it's going to be 15 plus r, right? Because you're going faster now. You're going down the river, the current is pushing you, right? So now we have to look at the time. So we know that we actually don't know how long it takes for this boat to go down the river. So let's just set that as t, and we know that the time to go up the river is going to be 1.5 times t, because it's 1.5 times as long as to go down the river, right? Now we just set up the equation, right? Because we know the time, we know that the time you're going up is going to be 1.5 times the time going down. So what exactly is the time going up? So we can actually find this. It's very nice if we go here. So from this we can get we can actually get the time is going to be let's just say time here. You can actually get the time here is going to be, the time going up is going to be 360 over 15 minus r, right? And the time going down is going to be 360 over 15 plus r. And we know that the time going up is going to be equal to 1.5 times the time going down, right? And then we just solve this. We just solve this, right? So let's just move this all over here so we can actually solve it. When you actually solve it, you're going to get let's see here. So 1.5 times 360, right? That's 360 plus 180, so it's like 540, right? So 540, 360 over 15 minus r is equal to 540 over 15 plus r. And we just, I need a calculator here. Let's see here. We're going to cross multiply. So 360 times 15 is going to be equal to 5,400 plus 360r is going to be equal to 540. Right, 540 also times 15 is equal to 8,100 minus 540 r. So then we can solve, right? So 360 plus 540 is going to be equal to 900 is equal to 8,100 minus 5,400, which is equal to this, right? 2,700, and easily we can see that R is, it has to be 3, right? Miles per hour here. So the rate of the current is 3 miles per hour, and you can plug it back into your equations to check, right? That's the good part. You can always check your answer. Right, are there any questions about this? This was a little bit harder, right? A little bit harder, right? Are there any more questions? If there are no questions, then I'm going to continue. So now this one does not require distance equal to rate times time. This does not require that. This is more about like percentages, right? And mixtures. So, however, this one is still pretty easy, right? If you think about it more. So this one is not too hard, even though it does not use distance is equal to rate times time. But it's just a mixture problem, right? And of course, it shouldn't be too hard. So I'm going to give you guys a couple moments to try and solve this. If you cannot, just wait for me to walk you through it. Okay, so let's do this problem. So let's see here. If we look at this, so this one is actually not that hard if you just think about it, right? So we have a mixture containing 80% alcohol. So let's just say 0.8, that's 80%, right? Of X. Because X is how many liters, right? So 0.8 of X should be added to 5 liters of 20% solution to yield a 30% solution. So 5 liters of a 20% solution. So 5 liters, 20% is 0.2, right? Times 5, And that's basically just 1, right? And we're going to have a 30% solution at the end, right? So that's going to be 0.3 times x plus 5, because actually we're adding the liters of x plus the liters of 5, right? So it's going to be x plus 5 at the end. So what we're essentially getting is we're going to get 0.5x is equal to 0.5 and x is just equal to 1 liter, right? So you just solve that equation. So that's basically what is a mixture problem, and mixture problems aren't that bad. So just remember to set up the equation correctly. So now we're going to use the little bit of time left to talk about complex numbers. It won't take long because complex numbers, they're quite easy to understand actually. So the definition of a complex number is actually all real numbers are complex numbers. So we write complex numbers in the form of a plus bi. So a plus bi here is a complex number where a is like maybe, for example, 3 plus 2i. That is going to be a complex number. 3 and is like a and 2 is b. And a and b are real numbers, right? They're like real numbers, okay? And I, right? So what is I? What do we define as I? So I is going to be an imaginary number. So I is going to be imaginary number. That's why we use I here. So what exactly is the imaginary number? Imaginary numbers are basically, you can define them as the square root of -1. So before when we solved these quadratics and we had the solution, that's because we were square rooting a negative number. But now we can use I, right? Because now we can simplify square roots, like the square root of -81, which is equal to the square root of 81 times the square root of -1, which is basically 9 times I, which is 9i. And we can simplify square roots like the square root of -64, which is equal to the square root of 64 times the square root of -1, which is equal to 8i, right? So now we can simplify those. So that's basically what a complex number is. And let's go over how to simplify these complex numbers. So case 1, when we're adding and subtracting, right? Basically, you treat it as like a variable, basically. So essentially, you're going to get like 7 minus 6 minus 3i minus 2i. So essentially, you're going to get 1 minus 5i, like this, right? You're treating it like kind of like in a variable. And when you're multiplying, you're also kind of treating it like a variable, right? 2 minus 3i, for example, like 6 plus 2i, right? Okay. Then you're going to get, you remember to distribute, right? So then you're going to get like 12 minus 18i, right? Minus 6i. And then you're going to get what? Plus 6. I think. Yeah. So actually, no, we don't. If you think about it, this is not plus 6. No, we get plus 4i. Okay. I don't know where I got that from. Plus 4i. Right. So now, why is this plus 6? Don't we usually have like negative 3i times 2i? So when you're simplifying multiplication like this, you have to remember that I is equal to the square root of -1. So I squared is going to be equal to -1. So when you square I, you're going to get -6 times -1, which is just equal to +6. And then what you're going to get here is going to be 18 minus 14i. Okay, are there any further questions on this? If there are no further questions, then I'll continue to division. So division is a little bit more complicated here, not that complicated, but so remember how we have to rationalize denominators, right? I'm sure you've all heard the term of rationalizing, like denominators, because you're gonna have like the radical in the denominator, right? Because it's just not how we like it. So they tell you to rationalize the denominator, but they usually don't tell you why you have to rationalize the denominator. And that's because you have better division, right? It's easier to divide 1.4 da da da. That's basically square root of 2 by 2 than it is to divide 2 by 1.4 da da da, right? So it's just for better division, right? And that's the exact same when you're working with complex numbers. So there should not be I in the denominator. So you're going to actually multiply this by its conjugate pair. And the conjugate pair is basically just changing the sign here, right? That's the conjugate pair, right? So the conjugate pair, we want that because now, as you can see, you can use difference of squares. This is difference of squares. So then on the top, you're going to get 12 plus 14i plus 6i is equal to negative 7. Well, no equal, a minus 7 here when you all simplify it. And you're going to get 4 plus 1 on the bottom. So you're going to get 20i plus 5 over 5, which is equal to 1 plus 4i. That's how you simplify the division like this. So that's how you simplify, right? So how do you actually use it in quadratics? So it's very simple. You just apply it, right? Actually, I do want to talk about patterns real quick. So let's just put it in a pattern here. So in school, they might ask you to do like, I don't know, like I to the 30th. Well, we don't know that yet, right? So I to the 30th, what does it equal? Right? We know that I squared is equal to negative 1, right? But what about higher power? So we can actually recognize a pattern. So I to the first is equal to 1. Well, I squared is equal to negative 1. Negative 1 here. I to the third is going to be equal to negative I to the fourth is going to be 1. But I to the fifth is actually going to be I again. So once you get I to the sixth, you see it repeats, right? It repeats a pattern, right? So we recognize this pattern here. I, negative 1, 1, and no. I, negative 1, negative I, and 1. That's the pattern. So when you're asked to find I to the 30th, essentially what you're going to do is you're going to divide 30 by 4. So 30 divided by 4, and you're going to find the remainder. So the remainder of 30 divided by 4 is going to be 2, right? Because of 30 minus 28. The remainder is going to be 2, and 2, the second term in this pattern, is going to be negative 1. So I to the 30th is negative 1. Now I to the 64, for example, actually that's a bad example. Well, I guess we could do it because 64 is actually divisible by 4. So then you're just going to get the remainder is going to be equal to 0, right? So then it's going to be 1. Right? This is going to be 1. And if you get remainder 1, it's going to be I. Remainder 3 is going to be negative 1. Remainder like actually negative I. Yeah. So that's basically all about this pattern, but it's very straightforward. So, and we won't do much with that. So now let's actually go on to quadratics, and I want to talk about the discriminant. So the discriminant is in the quadratic formula. It's going to be b squared minus 4ac. So the b squared minus 4ac is the discriminant. And when you have a discriminant that is positive, when b squared minus 4ac is positive, two solutions. Why? Because it's a positive square root, right? We can take the square root of that. No problem. When b squared minus 4ac is equal to 0, then there's only one solution. You call that a double root, right? One solution. Why? Because if you're taking the square root of 0, well, obviously it's going to be equal to 0, so there's no point in plus or minusing 0 because it's still going to be the same, right? So there's only one solution. And finally, when b squared minus 4ac is less than 0, then there's two imaginary roots with I in it. So if you look at something like this, let's see here, 2x squared plus 16x plus 33, we are going to get x is equal to negative 16, right? Plus or minus the square root of 256 minus let's see here. I'm gonna use a calculator. This 33 times 2 times 4. It's 264 here. And that's all gonna be over 4, right? So then x is equal to negative 8 plus or minus I to the square root of 2 over 2. So you see I here. Because we have a negative square root, we're going to have to use I, right? Are there any questions? If there are no questions, then that's all we're going to have for today, right? So today we learned about applications and complex numbers. Okay, infinity is imaginary. Infinity is not imaginary, William. It's just infinity doesn't really classify as a number, nor an imaginary number. So, anyways, that's all for today, and I will post the homework very shortly, probably tomorrow, right? The recording will probably be ready tomorrow, Kaylee. So, and I'll post the recording too. Okay. I'll see you guys next week then.